So the first technique I'll show you is how to create a predefined fractured object and simulate it with particle flow. The difference between simulating with particle flow and mass effects is we're going to simulate with mass effects within particle flow rather than outside, so that we can track how the particles move and how we can add some details into the final simulation. So right now this is one object, and if I want to break it into pieces, I will do that prior to go to particle flow, and in the second video we'll see how to let particle flow break it for you. But anyway, so we have a single object and I want to break it into pieces, so I can use ProBoolean with ProCutters. I can use various scripts out there that can break it into pieces, and in my case here I used a script called Fracture Voronoi, and what I did is I just put it into my my quad menus, and you just grab, and it's on scriptspot.com, so if you look for on scriptspot.com you will find Fracture Voronoi, and I'm just going to say break it, and it's going to break this object into 10 pieces, and you can continue on and select fragments of this object and break it into smaller particles. It's all possible. So if I grab this one and say break it again and break it again, it's going to break the object into smaller objects. So that's how I did this. I broke it into several smaller objects. I'll just hide what I just did and unhide what I've got here, and I'll just set the active layer. So those are my objects that I've fragmented from the main object. So this is just one way of breaking it. And if you're looking for professional solutions, there's also Rayfire and Volume Breaker. They are plugins to 3ds Max that allow you to break objects in much more refined pattern, I would say. But my goal here is to show you particle flow. So what I'll do is I'll press the 6 key, or I can go into the graph editor and say particle view toggle, and it's going to bring up particle flow. So I'm going to move this aside. And particle flow is our event-driven particle system, and in Max 2014 we've added a few operators that will allow me to do what I'm doing today, which is using physics within the particle system. So if I want to use physics or mass effects within particle flow, I can start with a basic particle flow and it's just a basic set of flows here. So if I just press play, what you're going to get is the particles are just going to fall down, and that's pretty much the basic simulation. So when we start with just a basic system like this, it's cubes falling down, and if we analyze what happened is we have event number 1. That's the only event we have in our flow. It's being rendered here, so that's just a top node to say that it's going to be rendered. But event number 1 is just the birth grid. That's the grid that we have here. There's a shape. It's a cube. The M shape is the simulation shape. Right now we see that it's colliding as a box. So we're going to leave it this way for now. There's a small spin in there, so that all of the cube spins spin a little bit. So if I want them to spin more, I'll say 15 here. And if I press play, you'll see that they're actually, let's make it a bit bigger so that it's a bit more obvious. Let's say 180, and you'll see that they're going to spin a bit more, and they're going to fall down like so. So it's just adding a bit of movement into this. If I don't want to have any spin, I want to have a pure physics simulation, I'll delete the spin operator and I'll press play, and you see that they're all going to fall pretty much in a straight fashion. The world is very important. If I press this little arrow here, it's going to bring me to the world simulation. So the gravity will be defined here. Also, if I go into the advanced parameters, this is where you're going to define the subframe factor, how many times you're going to simulate per frame. So you can you can simulate a bit more than on the frame. So all of these are defined here. The world, as we are going to do simulation, the world needs always to be the same. Everything that you want to interact with each other, if you have multiple particle flow event and you want them to interact with each other, it's going to be very important to use the same instance of the world. But right now, this is what we get. The display here is pink, so I'm just going to change that to a grayish color, something like that. And if I press play, this is what we have so far. So I want to replace the grid here. I want to replace it by the elements that we've got in our pattern there. So instead of using a birth grid, I'll use a birth group. And every item that has every operator that has a little star means that it's a new operator in 2014. So this one is new. I'll bring this in. The birth group allows me to pick any object in the scene and it's going to be replicated as a particle exactly at the location of where it is currently in the scene. So if you have an object that's been fragmented into multiple objects, that's the best way to turn it into a particle system. So what I'll do now is I'll just say grab one of these element. I'll right click and say select similar. All of these will be selected, and in the birth group operator here I can say particle object selected, and all of these objects will be selected. There's a nice little tool here called hide, and what it does, it hides the original object in the scene that have been represented here by particles. So I'll say hide, and you see that now all of the objects have been represented by particles. And you can see here that they're all cubes, which is exactly what we should expect, because the shape operator here has been we left it in there. So if I just say delete, now it's going to be represented by, it doesn't have a shape override, so it's bringing back the original shape. So that's what we have now. If I press play, you'll see that it's just going to kind of explode in all directions, and that's normal because the shape here is set up to be simulated as a box. And if you want to see how it's being simulated now, I can go here and say show me the simulation cage as a wireframe, and you see that all of these boxes, all of these objects are now represented by boxes, and all those boxes are overlapping, so that's why when we simulate they just repel each other and they go away. So if I don't want that to happen, I'm going to switch here from box to convex all. So it's going to create a convex all for all of the objects here. It's going to be a better representation of all of the particles, and if I press play, you see that it's going to fall apart like this. There's still kind of a bit of they repel each other a little bit. So what I can do is go back to the shape itself. I'm going to rewind, and in the tolerance here I'll give it a bit of room, so let's say 2. And if I press play now, we have a bit more tolerance, which means that if I you'll see it's just going to fall apart, something like that, and like so. I don't want to see the wireframe anymore, so I'll just turn it to none, and now what we have is this simulation like so. It's just going to fall apart like that. But what I'd like to do here is, now we have our simulation, we have our basic simulation. I'd like to add a bit of details to make it a little bit more interesting as it's falling down. So what I'll do is I'll take this event and I'll just copy and paste it as an instance. Now I don't need to have the birth anymore, so I'll just say delete. And that was happening in this event, in event number 2. It's exactly the same. The continuation of this event is exactly the same thing. So if I go here and I say, well, after a certain time, or when you reach a certain speed, or I'm just going to put a test in here to define when I'm going to go to that other operator. So what I'll do is I'll go into I'll add in a speed test, and the speed test is here. Just drag it in here, and just as a note, everything that is an operator that is of regular particle flow, it's a good idea to put it above the world, and everything that's affecting the physics system, and we're going to go a bit more into that a bit later, we need to place them under the world operator here. It's going to work better. But right now I'm just going to grab the speed operator, and I'll say whenever the test value is above 300 is kind of big, so let me just use a small value like 10. Whenever that speed test here is becoming true, you're going to move to that other event. If I want to know if that is working, I'll just grab the display operator here. I'll say make unique, and we're going to change its color, something like red, something like this, and now we're going to see when the particles are going to go into that second event. So as you see, as they start to accelerate, the particles are becoming red, and those that are just at the ground there, they just stay with their regular speed, their regular color, because their speed is not back to is not higher than 10. And actually 10 seems to be pretty much a good value. That's good, so we're going to leave it there. And I'll bring back here the display. I'll just grab the color itself and say copy, and I'll just paste it here to have the same color as we go through. So we know that it works now. We're going to continue from there. So what I'd like to do is I would like to have some debris or smaller debris, and I don't want those debris to necessarily be simulated in the physics simulation, because remember that everything that you do simulate in physics or physics, sorry, and Mass Effects, or whatever you want to call it. So Mass Effects is the official name, and it's actually the physics engine that drives the physics inside of 3ds Max. But If you want to have particles, every time that there's a collision, every time that you do a simulation of an object in physics, it's going to take computer time. So if you want to just have debris or dust or things like that, you may want to use very generic forces and affect the speed with those forces rather than having a full simulation, which is going to take longer to calculate. So what I'll do here is I'll bring in a spawn operator, which is an old particle operator inside of 3ds Max. Bring it up here. I want to spawn, and let's say that I want to spawn by travel distance. I'll just go here and say spawn by travel distance, and every time we're going to go through that step size, we're going to offspring one particle. We're going to leave it at 1 for now, and right now the speed is set to 100%. If I set it to 0, it's just going to leave a trail. So let's try this to see how it goes. And actually right now it doesn't emit anything, so I'll bring in a display operator just to display here and connect it here, and we'll display as something like lines will probably be good in this case here. And if I press play now, we're going to see that those particles are being emitted, but we don't see that much because we don't emit a lot of those. And I will rewind. Spawn by travel distance, spawnable 100%, and inherited here we'll say something like 120% with a bit of variation. Let's say, I don't know, 50% of variation, and divergence. The more randomness and variation, the more you're going to get. The more variation and the more divergence you're going to get, the better it's going to look. And the offspring here, I'll say maybe 5, so we have a bit more particles to look at. So now as these particles are traveling, you'll see that they're going to start to emit, and I hope you can see them here. They're going to start to emit, and they're going to continue with that same speed. If I don't want to have that speed, if we go back to what we had at the beginning, if I go back to an inherited speed of 0, the particles will just stay there wherever they're being emitted. So we're not going to see them that much, and as they fall down, probably going to see them better. Anyway, so we don't get a lot there, so I'll bring it back to inherited speed. We're just going to add a bit more, something like, yeah, we had 120 was kind of good because the particles kind of go faster and they go in the same direction as what they were emitted. The variation here, I'll say maybe 60%, so that we have a bit more, even like something like 80% will be good. The divergence, if we reduce it, they're going to be emitted in the same direction. So, but if we want them to be in all directions, I'll say something like 60% or more. The degree of divergence will be bigger. And then if we press play, you see that I wouldn't get those. But you see that they kind of go and they fall down and they always go in the same direction. If I want them to be affected by a force like a gravity, or a wind, I could add more to that. So let's say that we want to create particles that are going to fall down, and we want them to feel like they're being attracted by the ground, like small rocks or something like that. I'll bring in a force operator. Drag in the force here, and the force will affect the speed of those particles. And let's say that I want to delete them after a certain time. I'll bring in an age test, and I'll just drag this in, and the age test, we're going to set it to maybe 60 frames or 30 frames is good. We'll leave it to 30 frames, and after that age test, and actually, you know what, instead we're just going to drag the delete operators. It's the same thing. I'll say delete all. After, instead of creating another event, I'll say delete by particle age, and we'll say 30 with a variation of 10 will be fine. So some of them will be deleted at 40, some of them will be deleted after 20 frames. That's going to be good. So we have no force right now, so I want to affect by gravity. Again, if I did a full Mass Effect simulation, the gravity would be effective and it will enter in collision with all of the other particles. If I want a very accurate, precise simulation, I would just simulate them as a particle flow system. But I just want to affect the overall movement, so I'll go here and I'll bring in a gravity in the scene. I'm going to add it in, and now that we have that gravity pointing down, I'll go into the force here and I'll say add this one as the driver for the force. The influence is set to 1,000, so it's way too much. I'll say 50% here, and we'll adjust from there. And I'll just move this aside and press play. And you'll see that now they're going to go down, and they're going to be all pointing down. And after a certain time, they're just being deleted. So all of this, I could say, well, these particles here, I'm going to display them now that I pretty much know the color. I want them to be of the same type of color, and I'll just say paste. And now what we have is they're going to look pretty much the same color as the rest, like so. It's a bit too pale, so I'm just going to bring it something like this. and we have now the particles being simulated and emitted down. If I want to emit some dust or some smoke out of this, I can do the same thing. So what I'll do is I'll just grab the spawn operator here, and I'll say copy, and I'll just say paste inside of this. Actually, will it be? Yeah, it will be in, and I will just move this on the other side here. Just grab the connector. It's going to be on the other side. Again, it's going to throw pretty much the same thing. If it's a smoke, it's not going to go as fast. I'll say maybe 20% of the original speed, and I will display them. I'll just bring in a display operator. Display. I will display them as I don't know, circles will be different, and we're going to make that so that it's connected this way. So right now, not much is happening, and we're probably going to delete them by age as well. So I'll say copy and just paste it here so that they're being deleted after 30 frames as well. And if I press play now, not much forces. They're just going to stay there. It's not that interesting. So I would like them to be affected by a wind so that they're brought higher up as they are being emitted. So we're going to go back here. I'm going to add a wind into this. And if you want to have a good effect of wind, you can move that wind. You can add turbulence. You can make it spherical. In my case here, I'm just going to make that spherical. Add a bit of turbulence, maybe a 5, strength of 3, frequency, I don't know, maybe 5, and the scale here we'll leave it to maybe 10. So we'll see what we get as values with this. And I'll bring in a force operator, a different one. The force will be here. And the force, I will grab this wind here, so I'll say add this one by list. And of course, 1000% is way too much, so I'll do again 50%, and we'll see what we get from there. So play, and you'll see that now these particles are going up. It's kind of way too fast, so the wind, I want that to be a little bit more subtle. So instead of having a influence of 50, I'll say maybe 20, even 10 will be fine, I think. So I'm going to make it, small. And now that we've got that, press play. And it's going to be a bit more interesting. And if I want to have more kind of a variation in there, I'll go back again to my spawn operator, and I can increase the divergence here. I'll make it maybe 180, so it goes in all directions. Actually, it's going to be half direction, so let's say 360. So it's going actually 180 is the maximum, so I'll leave it there. And now you'll see that they're going to be a bit more spread than before, and we get kind of a smoke kind of effect as this is all collapsing down. So this is kind of the basic of how you can start to branch things and create events that had details, and you have a simulation. And that's the beauty of using particle flow rather than pure physics, because you're going to be able to trap certain things in certain events. So now we're going to go into the second video where we're going to let particle flow break the geometry. And also, we're going to trap some collisions, intercollisions, and we're going to emit particles as we break, elements of the geometry.